a few additional considerations when it comes to randomized control trials. You cannot randomize everything. There are practical and ethical reasons. There are exposure to smoking, asbestos, radiation. We don't randomize participants or individuals to that. You can't randomize pregnancy. I guess you can't randomize occupation. Maybe you can. You can't randomize heart attack and so on. So there are things that you can't randomize, and both for practical reasons and for ethical reasons. Non-compliance is certainly an issue in some trials. So people don't do what they are told to do. They don't take the pill. They don't use the app and so on. Those who are signed to a certain condition might also get access to the other one. So there might be contamination. So there might be individuals who it's not really defined if they were in the control or the intervention group, because they might have gotten access to the other group's treatments. And the intervention group might not comply, etc. Intention to treat is biased towards the null, since non-compliance from intervention group is a type of crossover. So if the intervention group doesn't actually adhere to your treatment, then they're quite much more alike the controls, which means that your intention to treat is biased towards the null. And because it should make the groups more similar and closer to each other. This is certainly something that, if you are able to measure it or somehow get an assessment of this in your trial, would be a strength, because then you could take that into consideration. The final consideration, an old friend that's going to follow you through life. Loss to follow-up, attrition. So results will be biased if data from participants are systematically missing. For instance, those who were not successful in quitting smoking might be less interested in responding to follow-up of a smoking cessation trial. Younger people might not be as easy to follow up as older people, or people who just didn't like participation in your study decided that they don't want to participate anymore and respond to your questionnaires and not come for visits. We could assume that missingness is not systematic. In that case, we assume a missing completely at random assumption, MCAR. In this case, we can analyze as normal. There'll be loss of power, or we could analyze with imputation. And as soon as I say the word imputation, I want you to add to that with caution. A lot of assumptions goes into imputation, and you should consult somebody that knows what they're doing when you deal with imputation. Anyway, here's a causal diagram that tries to illustrate the idea of missing completely at random, MCAR. You have some treatment or exposure or allocation to treatment in a randomized controlled trial. That has an effect on the outcome, but the outcome here cannot be observed. Rather, you observe Y star, and Y star is the incomplete data, so to speak. That's what you observe, but Y, if you could observe that, that would be the complete data. So the outcome or the exposure has some effect on the outcome, but you can't observe the outcome, so you observe Y star. The reason why Y star isn't exactly the same as Y is due to some component M, which is the mechanism behind missingness. But in this case, there's nothing that causes M. So M is completely random. There's no backdoors into M. And so missingness here is completely random. And that's when we have the missing completely at random assumption. If we assume that missingness can be explained by observed variables, then we have missing at random. We can use imputation with caution to analyze our results and get less biased results. Here are two diagrams that show you what's going on in a missing at random situation. We have allocation or treatment or exposure has an effect on the outcome. We cannot observe the outcome fully. We observe Y star, which is partial of Y. It's not all the Y data. And the reason why Y star is not the same as Y is due to some mechanism that causes random missingness. In this case, we see that treatment, allocation, or exposure actually causes the missingness. But and this is why we call it missing at random. So there's something that we observe which causes individuals not to respond. And because it's observed, we can actually adjust for it, and we can deal with this. And therefore, we can use imputation with caution to get an unbiased estimate. Or not an unbiased estimate, but a less biased estimate. Another situation could be where you have some characteristic, for instance, age, that you have measured that causes the outcome, that has a sort of an association with the outcome, I should say, but also an association with the missingness mechanism. But because you observed it, you can actually deal with it and you can account for it in your analysis. So you have still a missing at random assumption. But if you have missingness that depends on the missing value itself, or something that you haven't measured, then you have missing not at random, MNAR. Then we have sort of a self-fulfilling prophecy. You have less individuals drank alcohol at follow-up. Those who drank less were more willing to respond. Okay, so now you have an issue. Because now you're probably not going to get away with straightforward imputation. You're going to have to make some assumptions about the degree to which these results are biased. You have treatment, allocation, or exposure, which causes the outcome. The outcome is not observed fully, so you observe Y star. The mechanism which causes Y star not to be complete is caused by the outcome itself. This is a very tricky situation. Also, if you have something that you didn't measure, if, for instance, you didn't measure age, and age affected the outcome and the missingness component, mechanism, I should say, then you can't control for it because you haven't measured it, so you can't adjust for it, and therefore you have issues here as well. These are all assumptions that cannot be tested. This is what makes it so tricky with follow-up attrition. You cannot decide which one holds. It's impossible to know. No one will be able to tell you, and therefore you're going to have to make assumptions about your attrition and assumptions about how to deal with it in the best way.